One of the big factors, of course, in a network is that we need to provide end-to-end delivery of our service, and we need to meet those service level guarantees that we had talked about earlier. And so the process is referred to that of making and meeting that quality of service, QoS, or quality of service. So just mainly want you to be aware of that acronym. If you now go into your network properties, I mean, I'm not saying doing it right now, but when you look at the list of items that are installed on the network interfaces, we talked about file and print sharing, we talked about the TCP/IP protocol stack. One of the other elements in there is the QoS, or quality of service. That itself is a piece of software that actually is capable of identifying the traffic as it goes across the network. Is it data traffic? Is it voice traffic? Is it video traffic? Is it audio traffic? So all the different types of traffic, and then prioritizing through the routers, through the switches, which traffic should be forwarded ahead of the other traffic. QoS provides service management guarantees. The network has to be able to ensure individual applications are delivered according to agreed upon service levels. Applications must be able to be uniquely identified. So when they say applications, they really mean the type of data, and the networks must be able to respond then to the application needs on an individual basis. Should I forward it? Is it okay to hold it, queue it for a little bit? Bandwidth management, also a big aspect of the overall LAN management process, used interchangeably with a term called traffic shaping. Again, identifying the type of traffic that we want to allow through, we want to block, that we want to forward on a prioritized basis. Allocation of the bandwidth to support application requirements. These techniques and their associated technologies use either rate control or queuing. Queuing meaning that we hold on to it for a bit of time, or a combination of two, which of the two, both of those basically are utilized on most equipment these days. Traffic shaping devices will not improve performance of latency-constrained applications. This goes back to what we talked about earlier. Bandwidth and latency are not necessarily interrelated. It could be various server components or applications that are causing the slowdown, and so no matter how much we improve the bandwidth, not necessarily going to improve upon the whole entire process, because it might be some sort of a latency issue. So again, on our enterprise network management systems, we use agents, again, software programs. They run on networking devices such as our servers, our bridges, our routers, all intending to monitor, report the status of the devices. And the agent software has to be compatible then with the device that's reporting the management statistics. So usually when you buy a Cisco router, for instance, you know, they have their agents that you can install on there, and just, you know, any company you buy equipment from, if it's a large enough company, and if it's, you know, a piece of equipment that's used for enterprise purposes or LAN purposes, usually if they say it's a managed device, that's what they mean. A managed device means that it's going to include the agent software. Network management information, management information is gathered, must be stored in some sort of a database with an index, standardized field definitions. We've kind of gone through all of this stuff so that our workstation can easily access the data. So the MIB, again, the management information base, is, in the case of enterprise network anyway, that's the actual database format that is used in these types of systems. It says that the fields can differ based on the different vendors' networking devices. That's absolutely true. If you have a server running the DHCP service, you might recall that DHCP is where we dynamically allocate the IP address configuration to all the different systems out there. Well, a DHCP server has its own MIB, the DHCP MIB. The DNS server, remember, that's the Internet phone book where we store names and we assign them to the various IP addresses, right? It has named IP address mapping. There's a DNS MIB, because you're going to analyze different types of information on a DNS server than you are going to analyze on a DHCP server. So each MIB has to be different, and really it's just the field names are different. But a good management system, an enterprise network management system, would be able to handle all those different types of MIBs. The RMON MIB, which is the Remote Networking Monitoring MIB, is pretty standard in most environments, and that's where we get statistics like packets per second, IP datagrams per second, things of that nature. And partly due to the dominance of TCP/IP as our internetworking protocol, then SNMP, the Simple Network Management Protocol, is the de facto standard for delivering our enterprise management data. So again, that's just the transport protocol that takes the data and delivers it from the device to the management system. This is an alternative to the centralized enterprise management console system. What we talked about previously with regards to enterprise management was we only had one console in the mix. And so there's this particular architecture out there that is available. It's a lot more expensive than the previous ones we've been talked about. But Distributed Device Manager, or DDM, what it does is it relies on distributed network probes. And so what they show you is that there's an actual probe at each of the remote devices. They're capturing the data and they're carrying it over the network, and then they can be distributed to various management systems. It's not one of the best diagrams to illustrate that, though. We talked earlier about the WBEM, the Web-Based Enterprise Management System. This seems to be kind of the up-and-comer, something that we'll probably be using and is already in use in many locales. The whole idea is that we get benefits for both the vendors as well as the users. In the case of the users, they have to deal with only one common interface, so I don't have to learn a lot of different management system interfaces. Vendors can save a tremendous amount of development costs by only having to develop management applications for a single platform, meaning any web-enabled browser, more specifically a Hypermedia Management Protocol enabled browser, this one here, HMMP. So this is the transport that they use instead of HTTP or SNMP. HMMP is the transport that they use in our web-based enterprise management systems. And in fact, you should be familiar with these three acronyms when it comes to this particular technology. Hypermedia Object Manager, the HMOM, Hypermedia Management Protocol, that's the actual transport protocol, HMMP, and the Hypermedia Management Schema, or HMMS, so that's the database format. So here they're just showing you managed applications, blah, blah, blah. Now, earlier we talked about the fact that web-based enterprise management systems will support the existing protocols that are out there, so SNMP, DMI, but this is the one that is designed specifically for use by the web-based system. So it supports the older stuff. It's not going to be as efficient, though, when it uses these protocols. You can get much more data faster and much more information by using this particular protocol, the HMMP. So again, the HMMS is the database format. The HMOM is really just the type of objects that we're going to be collecting information from. And then in this case, they're showing you that utilizing HMMP, we can shoot it right to the internet browser, or using one of the older protocols, it can also have the data shared with some of the older management applications. So the flexibility of the web-based enterprise management systems, I think, is really going to help it win out. The overall intention of the architecture is that the network manager can manage any network device or application from any location on the network via any HMMP compliant browser. So all that's saying is the browser itself has to be able to support the HMMP. More than likely, it'll just be a plug-in like we add now, Shockwave plug-in or a Flash plug-in to be able to play Flash videos and whatnot, or Shockwave games. So you'll probably have a plug-in that you utilize for the web-based management systems that gives us that HMMP support. Existing network and desktop management protocols such as SNMP and DMI may either interoperate or be replaced by HMMP. All web-based management information is stored and retrieved by the request broker, formerly known as HMOM, now known as just the object manager. For some reason they took out the Hypermedia